This is Terry at Sirius. This is application note 319 on resistive touchscreen calibration. The project file for this demo is included with the application note. You can download it and explore it and import these concepts into your project if you want to have some setup screen in your project where the user can recalibrate the resistive touchscreen. All of our SIMs come pre-calibrated, but for some reason you may want to try and recalibrate or for whatever environmental reason. So this application note shows you how to put that screen and customize it into your GUI. So I'm going to actually show you on a SIM231 this project working. So let's just touch the screen. You can see my stylus. There it is. Now this first screen, it doesn't matter in the demo, in the project itself, if you touch the center of this first target. The goal here is to show people how to use the screen without training. You don't want them to have to read the manual or figure things out. So you can see I put the little hand over top of the target to show the idea of touching in the middle. And of course all this text could be turned into something that was translated as well. So let's touch, and the natural thing for people to do is to start touching right in the middle right away. If you try this in front of 10 people, 9 out of the 10 of them will make sure they touch the center of the target even on this first screen. They don't actually need to on this first screen, but it's a good idea. Okay, and you might want to test that and say, no, you need to touch the center of the target. But what happens, now we're in the calibration algorithm, and here they are once they get the idea of touching in the center of the target. I'll touch this one, and you can see my stylus coming over and touching, and touching. And now this screen is important. We will save the results of this calibration in non-volatile memory in the registry for following use even after a power up and power down, if you say save. And what we're doing here is saying any place on this screen that you touch will be a cancel except on this green arrow. And what that does is if for some reason they've just touched all over the screen, haven't done it properly, it is extremely unlikely they'll be able to touch in the green arrow. And anywhere else they touch will cancel it. So I'll do that now. I'll touch over there and it says you've canceled the calibration. And that's important because the last thing you want is wonky calibration data, bad data in the calibration system, because then they will not be able to control the touch screen after that. So you go back to the beginning, and this is a safeguard against that. So let's go through the process again, carefully touching each corner. And then when we're done, we're going to touch the green arrow, and it says success. And actually, now it shows the coordinates of my stylus. And if I go up in the top right, you'll see 479, which is the width of the screen, comma 0. 0 zeros over there. I'll bring this over here, 479, 281. So we've got all the corners perfectly done. And you can see as I move and hold my stylus, it's reflecting the position. So that is the demo, but that sequence of screens with the targets is the calibration process, which can be very much customized from a look and feel perspective. So now let's flip over into the project and deconstruct the project. Now that you've seen the demo in action, let's go into the actual calibration project for application note 319, the resistive calibration project. So let's go into the project. You've unpacked this on your disk, it's attached. And this was designed for a SIM231, but you can easily change this for a different SIM. To do that, of course, you just say File, Change Platform Variant, and you could change it, for instance, to a SIM225 and press Finish, and it'll regenerate the project for a SIM225. Just like that. Done. Now, let's break this project down and deconstruct its pieces. What you saw in the demo was this first screen, and then when you pressed this screen, it went to this touch calibration page with the target, and that target moved around to the four corners, and when you were done, you pressed the check mark or somewhere else. And if you pressed correctly, you went to this page, the success you recalibrated page, and if you canceled, you went to this one. So the demo had four basic screens. That's exactly this project. Now, the first page is very straightforward. You just press the screen anywhere, and you can look at how this is constructed. And we just have a single listener here that's listening for your touchdown on the whole page, and when it's done, it goes to the next page. Now, the calibrate page is where all the magic happens. Now, to take this and move this to your own project, let's find out what resources it needs, and then how the project's constructed on this page. It uses only a couple of images and a few pieces of text, and they're all in this calibrate assets group in the miscellaneous bucket. So there's a couple images, the target, the hand, the OK checkbox, the cancel. You can replace all these images with your images. there's a bunch of strings here where you can actually internationalize the touch to start message. So if you see this message right here, touch to start, it's coming from this asset right here. And if you want to be more polite, you could say, please touch to start. And of course that would change right there. If you wanted to internationalize it, you could internationalize it, and then as the language changed on the GUI, those pieces of text would automatically change. So you can play with the assets on this GUI, on this project, and then bring that into your project and make it look like whatever you want it to look like. But the flow has to be maintained in the sequencing. So the way this page is constructed is a few listeners on the page. So there's the standard page listener that makes this page visible when its time has come. So I'm not going to get into that. That's another app note. You've been through that. You can dig into that and figure out how that works. It's pretty standard. There are a couple of variables here, the OK page and the cancel page. So the way this is invoked from the splash page, let's look at how this page is brought up. When you press on that splash page, it sets pre-calibrate.OK page and pre-calibrate.cancel page to the child indexes of POK and pcancel. So boy, that's a mouthful. So let's dig into what that means. Get child index is a function. It's described in the documentation page under the built-ins. You can, in the wiki, you can type in get child index. It'll pull up the description of get child index. What it does is it looks at this object, POK, which is this one right here, this page, and it says get what index it is within its parent. So if you look at this parent D0, index 0 is this first thing, index 1, 2, 3, and 4. So get child index of this, of POK, is 0, 1, 2, 3. In child index of cancel is 4. So basically it's going to get child index of POK, which is 3, and assign the OK page to the number 3. And this number 4, it's going to assign there. Why is that important? It's like kind of making a function. I'm setting some parameters for the calibration page so that when you finally get through the calibration process and say OK or cancel, it will then transition to those pages that I've designated based on what you selected. And this is a little different page switch mechanism. We're going to create an app note on this. This uses the child index. So in this case, we set page, the global page variable, to get child index of the calibrate page, and everybody keys off this global variable page. And so what you'll find is under the calibrate page, the global variable, there's a listener to page, and it says if the page, that variable, equals the child index of my own page, that means I should be visible. So let's make me visible, otherwise make me invisible. And there's a state machine for the calibration. And the state machine is initialized here when we become visible to the start state. Okay, so when pre-calibrate becomes, the page variable is set to this guy's index, this page becomes visible, and it kicks off the calibration process. There's a group here called calibrate, and it has a state, that's a variable. And then there's a bunch of constants here. You notice that they're numbered -1, start is 0, pending is 1. So this is kind of like an enumerated type of all the different states that this state variable can be in. And there's a little listener in here under the variable that says what to send to the touchscreen calibration system when we enter that state. So as we transition through the state machine, in other words, touch left, touch right, touch bottom, touch the other bottom, we'll transition state through a series of states. Every time we enter a new state, we will send a command to the calibration touchscreen, this calibrate property of the touchscreen. And there's some codes. It's a 32-bit value with a high and a low section, 16 bits. And depending how it's coded, and you can go through this and see the codes, we're actually sending the coordinate 0, 0 here, saying expect the next touch to be 0, 0. Well, that makes sense. See, we're going into state left top. So we send to the touchscreen 0, 0 because we're expecting the user to touch at 0, 0. When we go into the right top state, we're sending to the calibration system glass width -1 shifted up by 16, so the X up here of 479, and the Y is 0, which is the coordinate that we're expecting them to touch at here. Similarly with right bottom, left bottom. And then confirm, cancel, and save have special magic codes that we tell the system to confirm our choice, to cancel it, and to save it. So that the process is go through the state machine just as you see it here in this order. Left top, right bottom, left bottom. Get all the touches. And then confirm our choice, saying we're done this process of calibrating. Now, at that point, you can still cancel or save it. It's not committed. All we've said is we're confirming we're done the process. And at that point, we can cancel or save depending on whether or not it was a good touch. And so depending on what state the state machine is in, we'll issue those commands to the touch controller. And we navigate the states by how we touch. So if you look at this first touch listener, let's make this a little wider so we can see what we're doing here. This is listening for a touch down on the page. Anywhere on the page, it's listening for a touch down. And what is it doing? Every time we do a touchdown, anywhere on the screen, this traps that event. And depending on what state we're in, we want to sequence the state machine. So the only state that we really care about is the start state here. And if we that's the state you're in when you first go into this page. And when you're in that and you touch the screen anywhere down, we go to pending state. In the confirm state, if you touch anywhere on the screen, it will cancel it. It goes to the cancel state. But there's an exception. So the way the touch listeners work is last best match. This is the first touch listener of a series. You can see all three of them, 1, 2, 3 here, right? There's actually one more kind of buried down in. If this is the best match and nothing below this matches, this will get the touch. So in other words, this confirm cancel, if you read the comment, you can go through it. Basically what it does is it says that when I'm in the confirmed state and I have the option of saving or canceling, if I press anywhere on the screen that isn't trapped by a touch listener below me, it's a cancel. That's important because we don't want to commit a touch calibration cycle if it isn't exactly right. So what we'll do is we'll have this catch-all touchdown on the whole screen. We talked about having this whole touch catch-all, and then we'll have a very small touch zone right here, a little farther down on the list. And if you press right in here, it will grab it. Otherwise, it will assume it's a cancel. And that's important because if your calibration is off, if they've miscalibrated, when they touch, it's very difficult if it's miscalibrated to touch inside the box, and that will automatically cancel, which is good because you don't want bad coordinates and bad calibration going into the system. So you see another listener here, and this is looking for touch up. And this is trapping the touch up in the pending state and going to left top. So what happens here when you go to that first screen, we're going to kick off this event. We wait for the touch down to go to pending, and we wait for them to release their finger on this initial screen before we go into the left top state. It's very deliberate. We're stepping through this process very one step at a time. And then there's another touch listener here that's if the event is calibrate. So in other words, once we've gone into the calibration system and set calibrate, delivered a calibrate command down into the touch controller, we are now going to get calibrate commands, not touch up and touch down. When we get calibrate events on the touch controller, we sequence through the different states to the confirmed state. Once we're in the confirmed state, you'll notice that there's the this box right here, the OK box. And if you notice, there's one more touch listener right down in here, listening for the touch down, and if it gets it, it says save. Anywhere else causes a cancel. And so you get this, and so there's no touch listener on the actual cancel button. There's only a script that sets the these two buttons visible and invisible when they get to that state. So the basic process, and you can go through this in fine detail as you walk through how this state machine works, and then clone it into your project if you want, is you enter the page, there's a state machine that's driven by this calibrate group and the state variable here. So the state variable starts at unknown and walks through these different states. And as it goes through the different states, it issues commands. That's what this listener right here under the state variable does. It issues commands to the touch controller called calibrate commands, which set the expectation in the touch controller that the next thing you're going to press is at this coordinate, or it confirms and cancels through some special magic codes. We walk the user through touching the left top, and this target is moved around depending on the state. So if you look at this target, that's what we didn't mention. If you look in this target, we actually look at the state, and depending on the state, we move the box around. So in the start state, we put the box in the middle of the screen, and it's visible. In the left top state, we make sure the box is visible, and we put it such that the center of the top left of the target is actually off the screen out in negative space here. And it's so the center of the target shows up right here. And similarly all the way down. And if it's not one of these calibration states, we turn that box off that includes the target, so the target vanishes. So the target moves around automatically based on the state. What we issue to the touch controller to say expect us to touch top left-hand corner, top right-hand corner, it gathers all that data, and when you say confirm and send it a confirm command to the touch controller, kind of locks it in temporarily so you can play with it with those new coordinates. And when you say save or cancel, the save commits it to non-volatile memory, factory default, or factory memory kind of thing, and that makes the coordinates survive reboots and things like that, so that you've now recalibrated your touch screen. When you do go into that final success, you recalibrated, and when you move your finger around, there's actually a little listener you can go look at, and it's somewhere on this page. We can go in and look at the different listeners, and you can find the listener that is listening to the touchscreen, and it's right in here. That's the one that goes back to the, that's the cancel. I'm looking at the wrong page here. Here's the OK page. And you can actually look and see where the text, here it is, this listener right here. And it's, as long as it's not a touch up, it's going to actually display the XY coordinate on the screen by setting this variable. And so you can kind of look through and see how it's picking out the XY location of your finger. So, in summary, state machine that walks you through the calibrate state, moves the little target around, expects you to touch in certain areas, you confirm it, and then you say save or cancel, and it locks it into non-volatile memory or abandons and goes back to the previous values. Feel free to go through the example. If you need some help, give us an email on support@myserious.com.